I've been expecting you. Hello, Year 9, and welcome to another week of remote learning with Miss Pitt. If you haven't done so already, please make sure you've completed your retrieval quiz for the lesson on the student worksheet that's been assigned. Pause the lesson video, go and complete your 10 questions, come back for your answers. Okay, so during chromatography, if a substance is pure, it only produces one spot. We should draw the baseline in pencil. Chromatography separates soluble mixtures. Can't separate insoluble mixtures because it won't dissolve. A solvent that you can use, water, ethanol, which is a type of alcohol, acid, you might have had something else written down. Number 5 is false. The solvent line should start below the ink samples. Number 6, the mobile phase is the solvent. Remember, the stationary phase is the phase that doesn't move, which is just the paper. Number 7, if blue litmus paper is put into chlorine gas, it turns red, then white. The chemical formula for hydrogen is H2. It's diatomic. There are 2 hydrogen atoms joined together. Carbon dioxide, CO2, is a compound, and to calculate RF value, you do the distance travelled by the solute. Remember, the solute is the solid being dissolved, so the ink or the dye, divided by the distance travelled by the solvent. So our lesson today is looking at how to test for positive ions by using a method called flame tests. So remember, this topic is all about chemical analysis, so looking at what components are found within different substances. And today we're going to be looking at how to test for salts, how to test salts to look at what positive ions are inside of them. So you need to be able to describe how to use a flame test to identify metal ions. So the title is testing for positive ions. The learning intention is to be able to test, to be able to identify metal ions. Now remember, back to our lesson on ions, metals always become positive ions. Now we will recap that in a moment. Keywords for today, positive ion, sometimes referred to as a cation, is an atom that has lost electrons and therefore has become positively charged. A flame test is a technique used to identify the positive ions in an unknown chemical. So just to recap, guys, so you know what you're testing for, we have had a whole lesson on, or in fact, we had 2 lessons in another topic on how ions form and what atoms form what ions. So just to quickly recap, remember, atoms are overall neutral, and when an atom loses or gains electrons, it becomes a charged particle. So remember, an ion is a charged particle, and it's either negatively or positively charged. Now, we're only focusing on the positive ions this lesson. So when an atom loses electrons, now remember, atoms lose electrons to gain a faux outer shell. So when atoms lose electrons, electrons are negatively charged particles. So if an atom is losing electrons, which are negatively charged, the atom therefore becomes more positive. And that is when it forms a positive ion. And if you remember, the general term for a positive ion is a cation. And remember, if you think back to the lesson, I remember cations being positive because they tend to reminds me of nice furry cats that are really cute and cuddly and make me happy. Also, when you have to write the word cat, as you write the T, it's almost like you're drawing a positive charge. Now, positive ions come from metal atoms. So, for example, lithium becomes lithium plus. So a lithium atom becomes a positive lithium ion. And try and think about why they have this charge. So lithium becomes positive by 1. Sodium, Na plus. Potassium, K plus. Now all three of these are in group 1 on the periodic table. Now remember guys, I said that they lose electrons to gain a full outer shell. If they're in group 1, they have 1 electron on their outside shell that they give away. They lose. And that's why anything in group 1 becomes positive. And remember, group 1s are metals, so we've got these positive metal ions. And if you look on your periodic table and you look at group 2, you've got magnesium. Magnesium loses 2 electrons, it becomes Mg plus 2, positive by 2. Calcium, also in group 2, becomes Ca plus 2. So anything in group 2 becomes positive by 2. Another metal you need to know about for this lesson, copper also forms a positive ion by losing 2 electrons, so it becomes Cu plus 2. Now, if you can't remember how to work out what ions they form, just remember that metals always become positive ions. So today we are testing for positive ions, which are metal ions. The only ion that is a positive ion that's not a metal is hydrogen. And that's why sometimes hydrogen's found at the top of group 1. So when heated, metal ions can give out a distinct colour. We can use these colours to identify the metals found in compounds. So you don't need to be able to hear this video, but I'm just going to show you how when group 1 metals are heated, how the metal ions produce colours. And the colours are distinct, so you can tell which metal ion is being produced. Keep loading, 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 loading. Yay. Lithium, nice bright red colour. Sodium, when sodium ions are heated, they emit a yellow colour. Potassium, nice lilac colour. Rubidium, cesium. Okay, so that's just showing you an example of when metal ions are heated, how they give out colour. And we can use that colour to identify metal ions in an unknown compound. So this is a required practical for GCSE, so you do need to be able to explain how to complete a flame test. So there's 3 different ways to complete what we call a flame test. There's 3 different ways to test for metal ions. So the classic method is using a wire loop, a nichrome wire loop, if you will, made of nickel and chromium. Now, if you can't remember that name, you can just say a wire loop. So in order to conduct this flame test, what you do is firstly you need to heat the wire in a blue Bunsen flame. Now that shows you if the wire is contaminated. So if you heat it in a blue flame and the flame changes colour, the wire is contaminated. What you then do is you dip it in concentrated hydrochloric acid. So you dip it in acid. Now that clears off any contaminants. You then dip it into the soap you are testing. So the compound, the substance that you're testing, you dip the wire loop into it to pick up some of the powder, some of the soap. You then hold it into a blue flame on the Bunsen burner and you look for a change in colour. So in this picture up the top, you can see it's given a bright yellow flame. So the blue heating flame has now turned bright yellow. And that is actually telling me that there's sodium ions in that sample. So just to run through this method, because as I've said, it is a core practical, you do need to know how to be able to do it. So testing for metal ions using a flame test. So step one, heat the wire loop in a Bunsen burner. And that's just checking to make sure the wire loop is nice and clean, it's not contaminated. Step two, and that's what the end of the wire loop looks like. Nichrome wire loop. Step two, dip the wire loop in acid. And remember, we've said that that is done to remove any contamination from the loop. It also helps pick up the sample that you're testing. Step three, dip your wire loop in the sample being tested. So there's an unknown sample. I want to know what metal ion is in it. I'm going to pick a small amount of that up on the wire loop. I then heat that sample in a blue flame on the Bunsen burner and I observe any colour change. So you can see here it's given a nice lilac flame and I know that that must therefore contain potassium ions. So there are 5 different flame colours you need to remember. So lithium. Lithium gives a bright red flame, sometimes called a crimson red flame. Sodium gives a bright yellow flame, and sodium ions are actually used in street lamps, in the inside gases of street lamps, and that's why it gives out a yellow glow. Potassium gives a lilac flame. Calcium gives an orangey red flame, so it's not bright red like lithium, it's more orangey red. And then my personal fave is copper, don't tell the others, and it gives a green flame. Reminds me of Harry Potter with the Floo powder. So there's 5 flame colours you need to know. Lithium is bright red, crimson red. Sodium is yellow. Potassium ions produce a lilac flame. Calcium ions produce an orangey red flame. And copper ions, when heated, produce a green flame. Now there's 2 other ways that you can carry out a similar flame test to test for metal ions. So the one that we've just looked at with the wire loop, that's the traditional method. Now the next one I call the easy method. So rather than using the solid soaked, the solid powder to hold in the flame, it's dissolved into a solution and then splints are soaked into that solution, so the soaked solution. So let's say you add sodium chloride, table soap, you dissolve it in, some people use some form of alcohol because as we know it's flammable, soak it in the soap solution, you can then hold the splint in the Bunsen burner and then you can see if the splint changes colour, changes the flame colour. Now be careful not to set a light to the splint, we're heating it to see a change in colour. And again guys, the colours produced should be red for lithium, yellow for sodium, lilac for potassium, orangey red for calcium and green for copper. And finally, another way that I would have showed you in the lab, unfortunately, we won't be able to do this, but when we get back, I will order it. I will book this practical. This is called the dangerous method. It's not called the dangerous method, but that's how I like to think of it because I feel feel a little bit dangerous when I do it. So spray bottles. So you pre-fill the bottle with a mixture of ethanol and the soap, again to turn it into a solution. Remember, ethanol is flammable as well. You aim the bottle into the Bunsen burner and then you spray it. When I am doing this, I will have a safety flame in front, and I will ensure that I'm spraying it away from the students, of course. Now remember, guys, lithium is bright red, sodium ions give a yellow flame, potassium gives lilac, calcium gives an orangey red, and copper gives a green flame. Right, task 1, you need to go to your student worksheet. You need to click the link to watch this video, and it's going to show you how to complete a flame test. Okay, so I hope you enjoyed the video. Flame tests are one of my favourite experiments to do in school, and hopefully, like I said, when we get back, it's something that I will look at booking for us. Okay, so task 2 on your student worksheet today is to complete the table by adding in the flame colour produced by each metal ion. Now, if you're stuck, I've given you the colours that you need to add in this box. Okay, so on your worksheet, you've got this table. You need to add in the flame colour produced. Pause the lesson video, come back for your answers. Ready for your answers now. Make sure you are marking your answers on your student worksheet as well, please, guys. So lithium is crimson red, sodium produces a yellow flame, potassium gives a lilac flame, calcium gives an orange red flame, and copper, the reason it's got 2 in brackets there is because it's copper plus 2 ions. Sometimes it can produce a different ion. For example, copper plus Cu plus Cu plus 2. And that's why in brackets is copper 2. Okay, so your next task, and this again is on your worksheet, all you need to do is add in the missing words from the sentences. So Mr. James thinks he is funny and has told Mr. Capstack, our technician, that he has contaminated a bottle of powder with a metal ion. Explain to Mr. Capstack how he could identify the metal ion Mr. James has used. So as you can see, Mr. Capstack's all ears, ready to listen to how he could identify the metal ion that Mr. James has contaminated the bottle of powder with. Now, if you're stuck, the keywords are in the yellow box. So those words need to be placed into the sentences. Pause the lesson video, come back once you've completed the task. Okay, so the answers are as follows. So Mr. Capstack could test the contaminated powder using a flame test. He could use a nichrome loop to pick up a sample of powder. Using a Bunsen burner on a blue flame, Mr. Capstack should heat the sample. The metal ion will cause the blue flame to change colour. Potassium will give a lilac flame. Copper will give a green colour. Sodium causes the flame to turn yellow. And calcium produces an orange-red flame. Okay, so that leads us on to the consolidation. So this is an exam style question. It is a 6-mark question, and it says a group of students had 4 different colourless solutions in beakers 1, 2, 3 and 4. The student knew that the solutions were sodium chloride, copper chloride, lithium chloride and potassium carbonate, but they did not know which solution was in which beaker. The teacher asked the class to plan a method that could be used to identify each solution. So think about what they could have done to find out what solution contained what metal ion. So you've got sodium, you've got copper, you've got lithium and potassium, but they don't know which one is in which. How could they test them? So pause the lesson video, complete your answer, unpause it when you're ready for your marks. Okay, so let's look at the marks. One should use a splint, so dip a splint into the solution. They would allow a mark if you said use a wire loop. Heat, once you've dipped it into the solution, heat it in a Bunsen burner, look for a colour change, so each one of these points would get you a mark. And then, guys, you need to make sure you say repeat the steps or repeat this process for the other beakers, for the other samples. If you didn't say repeat it, okay, how are you going to know which one's which? And you would have got a mark if you gave any of the positive colours. So sodium gives a yellow flame, copper gives a green, lithium gives red, and potassium gives lilac. And that leads us on to the very last part of the lesson. Remember, you need to rate your learning intention. So you needed to be able to describe how to use a flame test to identify metal ions. Are you red, amber, or green? Once you've done that, please submit your work so I can then mark it and provide you with feedback. Thank you guys for taking the time to access your home learning. I know it's been a long slog this time to complete all the work from home. Well done to those of you that have worked continuously hard, week in, week out. I know it's not easy, but thank you and well done for your continued effort.